welcome to another exciting day of geometry. Today we are going to talk about the surface area of cylinders. So yesterday we talked about the surface area of a prism. A prism was any three-dimensional shape that had two congruent and parallel bases. So the same thing is true for a cylinder, except for unlike prisms where it could have been a rectangle or a triangle or a hexagon, all the bases of a cylinder will always be a circle.
Ooh.
So no matter what, when you have a cylinder, your base is a circle. So looking at our lateral area formula yesterday for a prism, lateral area was perimeter times prism height. The cool thing about a cylinder is it's the same formula. Okay, but what do we have in place of perimeter when we talk about the distance around a circle? What do we call that?
Radius.
Close, we do
Diameter.
radius. Diameter is a line that goes all the way across,
Circumference.
passing through the center. Circumference. Circumference is the perimeter of a circle. So lateral area is 2 pi r, because that's our circumference formula, times the height. So this is our circumference. And then h, remember, h is the what? Height of the cylinder. Good. There's not really going to be any confusing pieces today because we're not worried about 1/2 base times height and a triangle base. There's not like double heights. But it's important that we remember when it comes to lateral area, height is the height of the cylinder or height of the prism, depending on what we're talking about. So it's circumference times the height of our cylinder. And then to get to our total surface area, again, yesterday, our prism was lateral area, which is perimeter times height, plus 2 times the base area, where the base area was replaced with the specific shape. So if it was a rectangle, base area was length times width. Triangle, 1/2 base times height. A cylinder will always have a base of a circle. So the base area formula is always going to be 2 pi r times the height of the prism. That's our lateral area. And then plus 2. And then what is the area formula for a circle? Pi r squared. No matter what, because base area of a cylinder will always be the area of a circle. So those are our two equations we're dealing with today. Lateral area is 2 pi r, which is circumference times the height of our cylinder. And then total surface area is 2 pi r times height plus 2 pi r squared, because pi r squared is the area of a circle. Ready to tackle some problems? So, looking at our cylinder on the left, okay, the cool thing is we don't got to identify what the shape is. We know the shape is a cylinder. Looking at our cylinder, lateral area is 2 pi r times the height of our cylinder. What is the radius of our base? Essentially, it's the radius of the circle. 3. So 2 times pi times 3. And then how far is it from the top of our cylinder to the bottom of our cylinder? 7. So we're going to leave our answer in terms of pi. Okay, to leave our answer in terms of pi means we're going to treat pi like a variable. We're not going to multiply by pi. If I asked you guys to multiply 2x times 3 times 7, what would your answer be? 2 times 3 is 6. 6 times 7 is
42.
42x. Thank you. That was a great job, buddy. Okay, so the same thing is going to be true here. We're just going to multiply our numbers together. 2 times 3 times 7. Okay, and we end up with 42 pi meters squared. Remember, we use our units to keep our science teachers happy. 42 pi meters squared. And then if it asks you to multiply by pi, it's going to either ask you to use the pi button, which is what I prefer, or it's going to say 3.14 or 22 over 7. Just make sure you read your instructions clearly. But for the sake of this, leave your answer exact in terms of pi, because that's the best answer possible. Total surface area is that lateral area, 2 pi r times height, plus 2 pi r squared. We know our lateral area is 42 pi. And this one is 2 pi times 3 squared. So we've got to make sure we follow our order of operations. PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Before we can add them together, we need to make sure we multiply. But before we multiply, that exponent has to happen. So 42 pi plus 2 pi times 9. 2 times 9 is 18. 42 pi plus 18 pi, are those like terms? Can we combine them? Yes.
60 pi.
60 pi, and then to keep our science teachers happy, meters squared. Number 2. Lateral area is simply the circumference, 2 pi r, multiplied by the height of our cylinder. How far is it from base to base? So what is the radius of this figure? Because they gave us that 21 number, but it goes all the way across. So that's our diameter. So to find that, we're simply just going to divide it in half. 10.5 is our radius. Does everybody agree with that? I hope so. So then we got 2 pi times 10.5 times the height of our cylinder. How far is it from the one base to the other?
3 centimeters.
3. So 2 times 10.5 times 3 is 63. And then to keep our science teachers happy, centimeters squared. Surface area is that lateral area, 2 pi r times height, plus our base area times 2 pi r squared. 63 pi, 10.5 squared. 10.5 squared is 110.25. Times 2. 220.5. What's up?
I was just saying 220.5.
Thank you, buddy. And when we add that to 63, 283.5 pi. Centimeters squared. Remember, leave it in terms of pi, treat pi like a variable, just bring it down with you. Number 3, put in our favorite piece, a radical. I know you guys are excited to see radicals make their comeback. So lateral area is 2 pi r times height if my diameter is 12 root 2, my radius is half 6 root 2. Why did I not divide the square root of 2 by 2? So when I did that division, right, so if I like draw it out, 12 root 2 divided by 2, why did the 2 only apply to the whole number on the outside and not the irrational number on the inside?
But then you divide by 2, there's not a root 2.
Right, if there would have been a root 2, we would only have applied it to the root 2. In this case, it's only going to apply to that whole number. Remember, outside numbers with outside numbers, inside numbers with inside numbers. So 2 pi times 6 root 2 times how far from the top to the bottom? 6. 2 times 6 times 6?
72.
72.
On that.
72 root 2 pi. Use our units, keep our science teachers happy. Now it's going to get a little wonky when we square it, isn't it? Does anybody see why? So lateral area plus 2 times our base area. So when I take that lateral area, 72 root 2 pi, I'm going to zoom in here so the folks in the back can see a little easier. But we get 2 pi times 6 root 2 squared. When we square a square root, remember that 2 is going to distribute to the 6, that 2 is going to distribute to the square root of 2. So we end up with 72 root 2 pi plus 2 pi times 6 squared is
36.
36.
Why don't you do like SA equals LA plus 2 pi r squared?
You can. I just wrote out 2 pi r times height.
And then why do we write the like LA like not squared? Because at the end of the equation we have it like
The feet squared.
Yeah.
You talking about where does the feet squared come from?
Like no, like why do we not write it whenever we write it in like the essay formula?
Oh, because in my experience, when we write that feet squared in there, it kind of confuses people. So I just say save it for the end. You can though, if you wanted to put feet and then feet, you just got to make sure you don't let it confuse you. Okay. So 6 squared is 36, and then the square root of 2 squared. Close. It is the square root of 4, which is 2. So why is this multiplication? How does this stay multiplication? What was holding the 6 and the root 2 together in the first place?
The invisible 1.
The invisible 1. Well, we don't need an invisible 1. We have the 6, but there is multiplication holding them together. So even when that radical gets canceled out, it's still multiplication holding them together. So now we have 72 root 2 pi plus 2 pi times 72. My final answer, 144 pi plus 72 root 2 pi. Why did I not put these two numbers together?
Because
one of us
square like terms.
One of them has a square root and the other one doesn't. These are not like terms. If you think back to your Algebra 1 days, it would be like saying 144x plus 72xy. Are those like terms?
No.
No. So we can't really just combine them.
Where did you get the root 2 from on 72? Because
That was from our lateral area. So when it was 2
Oh.
times 6 times 6, the square root of 2 stayed. But when we did surface area and we squared that square root, our square root disappeared. So that's how they ended up not being like terms. Good question. Think that one. Okay, so this time they hit us with a right triangle. You cannot escape right triangles in geometry. Okay, so it told us this hypotenuse was the square root of 2. What are these two lines? What do we know about these two lines? They're both what?
The same.
Why are they both the same?
So
Now?
45, 45, 90.
They are both radii, and in any circle, radii are always congruent. So because my sides are congruent, our angles have to be congruent. So it is just a 45, 45, 90 triangle. So if you wanted, you could use the Pythagorean theorem. But because we recognize our specials, we're going to go ahead and do our special. So leg to hypotenuse, any number divided by itself is always 1. So my radius is 1. That was amazing. Great job, guys. So lateral area is 2 pi r, which is our circumference, times the height of our cylinder. So 2 pi times 1. And then how far is it from the back of our cylinder to the front of our cylinder?
6.
6. Simple answer, 12 pi. Surface area, you could write lateral area if you want to. But just so we show where our equation's coming from, 2 pi r times height plus 2 pi r squared. So lateral area plus 2 times the base area. We get our lateral area we found was 12. And the nice thing about a radius of 1 is it doesn't matter what I end up squaring it. It's just going to be 12 pi plus 2 pi, which is 14 pi. Oh, we almost forgot our units. Chemistry teacher's going to yell at us. Inches squared. Oh man, they didn't make this one as easy on us, did they?
Dang it, Peter.
Darn it, Peter. It is not going to come out to a nice, pretty 1. So again, if you want to rock the Pythagorean theorem, a lot of you guys might find the Pythagorean theorem easier here because you're going to have to rationalize. If not, let's go for it. So 1 over r is root 2 over 6. Okay, leg to hypotenuse, our ratio of 45, 45, 90 is 1, 1, root 2. So we get r square root of 2 is equal to 6. Divide by the square root of 2. So r is equal to 6 over the square root of 2. Yes?
How would you be able to use the Pythagorean theorem?
R squared plus r squared equals 6 squared.
Like I had to have 2 sides.
We do. We know the radii are both the same. So r squared plus r squared becomes 2r squared. That's a good question. And then times square root of 2 on the top and bottom. We can't have that in the denominator. So 6 root 2 over 2, which reduces to 3 root 2. Do you want to run through a Pythagorean real quick?
Yeah.
Yep. So we go r squared plus r squared is 6 squared. How many r squareds are there on the left?
2.
2. So 2r squared is 36. Solving for r, we're going to divide by 2 first. So r squared is 18. And then we take the square root. But that's why we got to make sure, because now we got to break down it. 9, 2. 9 breaks down to 3 and 3. So that's how we end up with the same 3 root 2. If you do special rights, you're not going to have to birthday cake or trick or treat. But it might be a little easier because it's such a small number, it's not that bad. All right, so we know our radius is 3 root 2. So lateral area is 2 pi r times the height. 2 pi times 3 root 2 times how far is it from the top to the bottom? Good, started from the bottom, now we're here. Okay, 2 pi times 3 root 2 times 3. 2 times 3 is 6, times 3 is 8. 18 root 2 pi squared. Surface area is that lateral area times the height plus 2 times our base area, which is pi r squared. So 18 root 2 pi plus 2 pi times 3 root 2 squared. Remember, this piece is what gets kiddos tripped up. That 2 gets distributed into both terms. If you put it in your calculator like this, all your calculator sees is square 2. You can put this number into your calculator. Just make sure you use parentheses the same way I use parentheses. So your calculator knows the square root of all of it. 18 root 2 pi plus 2 pi times 9 times 2, which is 18. So we get 36 pi plus 18 root 2 pi. Can I put those two together?
No.
No, because they're not like terms. I know, when they add radicals, it makes it a little tricky on us. What's wrong?
I can't draw the pi.
You can't draw the pi? It's okay. It takes practice. Do your best. Some people just go box and like this, like straight across in the little 2 tails, each one, like a little Stonehenge. I had one kid doing like an H lap class. That was a while ago. Okay. And then one more. This one's going to be pretty straightforward. The lateral area is circumference, 2 pi r times height. So 2 pi times 2 root 2. What's the height, top to bottom? 5. 5. So 4 times 5 is 20. So 20 root 2 pi. Square centimeters. Surface area is that lateral area plus 2 times our base area. 20 root 2 pi plus 2 root 2 squared. Again, you can put that right in your calculator as 2 root 2 squared. Just don't forget to use parentheses. That 2 gets distributed into both terms. So that's 4 times 2. 20 root 2 pi plus 2 pi times 8. So we get 16 pi plus 20 root 2 pi centimeter squared.
Where'd you get chewed up and say?
Go ahead, talk to me.
How'd you get 4 times 2?
What's 2 squared? So if you look at it, 2 squared is 4, and then square root of 2 squared is 2. And that's where we got 8 from. Great question. So for these last two, we're going to reverse engineer some of the information we had. So for the last one, they gave us height, they gave us radius. we didn't have to work too hard. On this one, they're gonna hit us with different pieces of information. They're probably gonna give us lateral area and surface area, and then ask us to find either the radius or the height of our cylinder. Okay, in this question, it says the lateral area of a circular cylinder. All cylinders are circular in our case. So remember, equation is 2 pi r times height. It wants us to find the diameter. The equation doesn't give us the diameter straight up, but it does give us a radius. So what we're going to do is plug in what they tell us, solve for r, and then double it. So lateral area is 48 pi plus 2 pi times our radius times our height, which is 6. Take care of our order of ops. We need to do that multiplication. So 48 pi is 12 pi r. We are solving for radius, so we're simply going to divide both sides by 12 pi. And we end up with a radius of 4. Diameter is twice the radius. So 2 times 4 is 8. And last one, surface area of a cylinder is 96 pi. If the radius is 4, find the height. Okay, total surface area formula. If I can get a blue pen, that'd be helpful. Surface area is 2 pi r times height plus 2 pi r squared. It gives us radius, wants us to solve for height. So 96 pi is 2 pi 4 times h plus 2 pi 4 squared. So our variable that we're trying to solve for is h. So let's go ahead and reduce that stuff on the right. We get 8 pi h plus 4 squared is 16. 16 times 2, 32 pi. We need to move that 32 to the other side. How do we undo addition? With subtraction. Good. Okay, so we subtract 32 from both sides. 96 minus 32 is 64. How come we could put those two together? Why couldn't we just subtract them? They were both in terms of pi. We can always combine like terms with addition or subtraction. Final thing, divide both sides by 8 pi. So our height is 8 inches. That's going to do it for our lesson today. Go be great.
Like it's right.
There you go.